Okay, we're continuing with section 7.3, and we're talking about part B. And I left off with what probability was. The probability of an event is equal to the cardinality of the event, that means a count, over the cardinality of the sample space. And we haven't done too much of it, and we've kept them in fraction form. But now we're getting into cards. And for those of you that are unaware of cards, we have two sets of red cards. And they add up to 26, 13 and 13. Two sets of black cards. And they add up to 26. So our total sample is 52 cards in a deck. All right. And then we have hearts, clubs, diamonds, and spades. On each one of these, there are 13 of them, up to 52. Now, this part right here are called face cards. The king, queen, and jacks in a deck are called face cards. And there are 12 of those. Aces are not face cards, and there is 4 aces in a deck. Then you have all of the numbers, 10 through ace, and they are all 4 of each. And so now that we know parts of the deck of cards, we can look at probability of an event. So here we have, for an event, any event E, the following holds. The probability is between 0 is less than or equal to the probability of the event less than or equal to 1. So this gives us an idea of the prospectus of the realm or the domain of probability. Right here is 0.5 or 50%. And then right here is a quarter, 25%. And here another part is 0.75. And then we have the 1. The 1 is the same as 100% if we changed it to a percent. But these are the ratio representations. This is unlikely to occur if we have a 0. This is a certainty. We have a 1. This area here is where the probability should be if you want success. This is too low after that point. That's what they're mentioning here. If an event is a certain event, then you get the 1. If it's an impossible event, you get a 0. All right. So now we're going to do some probabilities. They're not difficult. We're just getting an exposure and understanding how to construct them. A single fair die is tossed. So our sample space is 1, 2, 3, 4, 5, and 6. That's our sample space on the single die. Find the probability, and this is our event, number greater than 4. All right. So this is our probability structure, that it is greater than 4. Well, greater than 4 is only 2, the 5 and the 6. So the event is the set of 5 and 6, which the cardinality is 2. So it's 2 out of 6, or the probability is 1/3. 1/3. All right. So this is the structure. These are the components of, and this is theoretical. Because we know how many are in the sample and we do a single, we assume we get it. So it'd be 1/3, 1 in 3. A card is drawn from a well-shuffled deck of 52. So the cardinality of our sample space is 52. Find the probability of drawing an 8 or a 3. So this is or. Above we said if it's or, then we add the probabilities. And these are independent. So we're going to write it. So we know we want the cardinality of 8, which is 4 in the deck, and the cardinality of a 3, which is 4 in the deck. All right, so now we're going to structure it. We want the probability of an 8 or a 3. So that's going to be the probability of an 8 plus the probability of 3. So the individual probability is 4 out of 52 and plus 4 out of 52 for the 3s. And that gives me 8 out of 52. If I simplify by dividing by 4, I get a 2. And if I divide this by 4, I get a 13. Oh, I can't do math. Sorry about that. If I did 4, yeah, I did right. 2 out of 13. Is everybody comfortable with that? Hey, I better circle that. Here's another problem, and we're still talking theoreticals. A jar contains 4 white, 2 orange, and 3 yellow marbles, and 5 black. And that's what it has. So let's add up our sample space. So this is 6 and 14. Is that correct? Oh no, I did bad math on that, didn't I? Because that's 5, 10, that's 20, I think. 6, and oh, that's a 5. That's where I went wrong. Write it correctly. I'm doing my math all cockeyed. 6 and 8. Yeah, 14. I doubted myself. Sorry about that. All right. So I have my sample space. Now let's see what the question is. If a marble is drawn at random, find the probability that the marble is not yellow. So yellow, not. So that is 1 minus the probability of yellow. And that's how we would do it, because it's everything that's not yellow. And in yellow, it's 3. 1 minus 3 out of the 14. So that makes it 11 out of the 14 possibility. It's 11. It's more highly likely. That's pretty close. Empirical event occurs when n repetitions of an experiment, then the empirical probability is the event F is F over n. All right. Still, it's the same as what we did before, but here we go. Is the following an example of empirical probability? The probability of a freshman entering college, let's see what that is, entering college will not graduate. Is that empirical? And that is empirical because we're having in this case, a cap F of an event, a lot of them, and a prediction. and that means previous information or data collected. So this is empirical. All right. The probability that a person will get a heart disease from a poor diet. That is not empirical. Oh, yeah, it is. It is. Yes, because it's a heart disease. Yeah, it is empirical. All right. Now let's use this knowledge. Mr. D's grocery store is offering grocery gift cards giveaways to one lucky customer. 5 gift cards valued at $5. 20. Oh, no, they're individual. Sorry about that. The total is 5. I misread. That goes to show you. Let me do this again, guys. Here we go. The grocery store is offering a gift card giveaway to one lucky customer. 5 gift cards valued at 5, 20, 40, 150, and 500 respectively are placed face down on the table. The customer will randomly select 2 of the 5 cards. All right. So we have a $5, a $20, a $40, a $150, and a $500, respectively, are placed face down. The customer will randomly select 2 of the gift cards. Identify the sample space consisting of equally likely outcomes. The set of these gift cards. So that's that. Got the gift cards. All right. Determine the probability the total amount on the 2 selected gift cards is less than 150. Less than 150. All right. So our event implies, let me make more space here. Okay. So the 2 ones are less than 150. So we could have the 5 and the 20, the 5 and the 40, the 5 and the 150, the 5 and the 500. All right. Then I could have the 20 and the 40, the 20 and the 150, the 20 and the 500. Then I could have, because I did the 20s, now the 40, and each one will be less. 4, 3, I am almost there. 40 times the 150, and the 150. And let's see what I have here. 40 and the 500. And that leaves me the last one, the 150 and the 500. All right, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our sample space is 10. And they want gift cards is less than 150. So we know all of these here are not going to make it. All right, this part here. So those are all over 150 because they have the 150 card in them, and this one too. So this one is not included. So we have this one, and that's not, this one, and this one. So we have 3. So the probability that the gift cards are less than $150. And that would leave me 3 out of 10. 3, 6, 9, 10. Yep. I'll highlight them. Less than 150. That does it. Alrighty then. Because he's taking up 2 at one time. All right. So let's look at this next one. Determine the probability the total amount on the 2 selected cards is more than 150. So that would make it 7 over 150, over 150, over 150, over. So those are the 7. Oh, it's more than 500. Sorry about that. I'm going to have to go back. I thought it was 150. It's 500. So the 500 is only this one and this one and this one and that one. So it's one more than 500. So this is 1, 2, 3, 4. 4. I have 4. 2/5. All right. So now we have that. Now we've got this guy right here. There were 2,468,444 deaths in the county in a certain year. They are listed according to carrier in the tables. So our total is 2, 4, 6, 8, 4, 4, 4. All right. It says the probability the cause of death was heart disease. All right. So that would be this one here. And it would be 5, 9, 7, 6, 8, 9 over that 2,468,444. So let's look at that. Get my calculator. So I'm going to put in the 5, 9, 7, 6, 8, 9 divided by 2, 4, 6, 8, 4, 4, 4. Enter. And then I'm going to go math frac. And I get, and it won't do it. So this is good. This is the probability. And if the computer wants a couple of decimals, it's usually 3. It's 243. 242. Which makes it 24%. All right. Let's see what the other one is. Probability of the cause of death with cancer or heart disease. Oh my goodness. All right. We need some space for that one. All right. So we wanted probability of cancer. Oops, that's a C. Or heart disease. So if we want those, they're the individual probabilities. So we would have in cancer, what did we have on cancer? 5, 4. No, I'm sorry. 5, 7, 4. 7, 4, 4 over that 2,468,444. Or, that means add, heart disease. 5, 9, 7, 689 over that same denominator. All right, now we're going to add only the numerators on the calculator so that we can get the solution. And I would enter 5, 7, because the denominators are alike, 4, 7, 4, 4. That one. Plus 5, 7, 4, 7, 4. Good. 5, 9, 7, 6, 8, 9. And I get this great number. 1, 1, 7, 2, 4, 3, 3 over that 2,468,444. Now, if it asks for decimals or percents, you follow that. You have the ratio and then stick it in the calculator to get that answer. So here we are at the last one. Okay, so the probability that the cause of death was not accident and not diabetes. All right, so that means one, the probability of accident not, and diabetes not. All right. So we're going to add those two together over that 2 million and then subtract it from 1. And that was Sadie, quiet. Diabetes and accident. All right. So I'm going to have the 120857, the 69078, 15, 13, 9, 9, 8, 1. So 189935 over that 2,468,444. My goodness, my pen. 68444. And there you have it. I would subtract it. 1 minus 189935 divided by 2468444. Oops, it should have been divided. There you go. So it's approximately 0.923. And that's what we're going to leave it at as a decimal. Okay, guys, we have covered probability. We've done theoretical and we did empirical, and that's data collected. And we've done experiments as well. We didn't do a whole bunch on that, but we have the empirical, which is a collected data. So now you can do it. I've done it with structure and with understanding what we're looking at. Now it's time to do the homework. Thank you for listening.